Welcome friends, and let's talk about the decimal. Decimal are basically the fixed point and the floating point arithmetics. So decimal is basically based on a floating point model which was designed with the people in mind. Because normally, as a programmer, we and you know there is a binary floating point decimals where when we calculate multiplications or divisions, we get a output in a format of more precise format. But in a day-to-day life, for computing or you can say for the normal people, we need an output that is less precisely. For example, if you use 0.1 plus 0.1 plus 0.1 minus 0.3, in what we expect from this one, okay, we expect from this is 0. So this can be done by using decimal. But if you are trying to calculate this arithmetic problems by using the binary, you will get an output that is result something like 5.5 blah 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 exponential 017. So this is what exactly we didn't want in our calculations. We want a sophisticated and simple to answer value that is the 0, because we know when we do a normal calculations, when we add this 0.1 plus 0.1 and make a subtraction of 0.3, we were expecting 0, okay, and this can be done by using the decimals. So the decimal means the computers must provide an arithmetic that work in the same way as the arithmetic that people learn at school, except from the decimal arithmetic specification. This is what exactly had covered in the Python. So we will talk about decimals and what are the methods, what are the functions available in the decimals, how we can use the decimals. So let's see. If you want to use the decimal, my friend, first and the foremost thing that you need to do out here, you need to import all the classes available in the decimal modules. So you can do it something like this: from decimal import all. So this will import each and every things. The next thing, you need to set the precision. For example, there is a function available. That function name is getContext, like this. So when you run it, you will see that there is a constructor available for this context that says the precision of the calculation when you use the decimals is up to 28. You can short it down to 6, and rounding means how much you want to round off your output is the half, and in case of even, what should be the minimum and the maximum value that it occur is it given it here. Same way, what to do if there is some kind of traps available, like invalid operation, division by 0 and overflow. Let us take an example here. Let's say I'm going to set the precision PREC. So this is the way how you can use it. getContext.precision. I'm going to set it to 6. And when I do some kind of calculation, so to use a decimal, you need to use a class named decimal. And in a constructor, you can pass a value. You can also pass strings and strings. That is basically means that just contain the number. So for example, if I use decimal 1 divide by decimal, let's say the 7, and when I run it, so you can see out here I got the precision of something at 1, 2, 3 and 4, 5, 6. Now let's see once again if I need to do the same, and when I run it, see I'm getting a very long output, okay, it's something about up to 28 precision or whichever long last. So whenever you do this kind of calculations, you can shorten your precisions by using the getPrec. One thing that you need to remember here when we do the calculations by using the decimals, you can use strings. So here you can see when we talk about the decimals, okay, you need to import it. You need to import, okay, we already imported here. So if you are not importing everything available in a particular module, only you are importing the decimal module, you need to specifically use the dot operator to go call the functions or to call the classes available in that particular module. So here in this example also I'm just using the 30, okay, I'm just using a decimal 30. It will give me an output of number that is decimal 30. You cannot directly use the decimal if you are not importing means all the modules from the decimal module. So this is not possible. And one more thing that you need to check it out here, okay, you can give an input, something like you can give an input of a string. You can see this is a string, but it's a number. So if you are giving a wrong input, what would happen, my friends? It would be give a invalid number error, invalid operations, invalid number. So here you can see I'm using here 3.14, which is basically in a string. When we run it, it will give me a decimal format, okay. Same thing, you can find out the type of a particular data type. For example, here the F, we know the F is basically decimal. So when you use a type, it will be, okay, this is a decimal. And what exactly the decimal exactly is, it's a module. You can see this is a module. It's a module. So my friend, if you try to run something like this, let's say when let's have one new cell here, and if I use type, let's say decimal, if I run it, see, it's the type. So decimal is a module, and small case, decimal is a module which is a collection of various types available inside this particular module. Next thing come here when we type, okay, here once again you can use everything, you can import it, you can set the precision, something like this. And normally when you divide a number, for example 1 by 7, you can see it will give a long precise value. It will give a long precise value, but you can set the precision from 28 to something. You can say you can set the precisions to 6 or 5 or 2. So here in this case scenario, if I try to run something like this, get context and here dot prec, and let's say 2, I want my output in a 2 decimal value. If I run it, see, it will give the same. Why? Because this is not treated as a decimal, this is treated as a number. This is treated as an integers, and after division it is treated as a floating, binary floating point. Okay, so that's why it is giving this huge output. So if I change something like this, if I just copy this part from here and paste it here, and when I run it, you can see we were getting an output of to 2 precisions. And some more example available here. You can use the string. Okay, you can use a decimal 3.14 when you give an output. Okay, so this is a major difference available here. Suppose if you are going to use a string, you can see this in a string, and we know inside the string this is a floating point value. When you run it, it will definitely give an output as the same. But if you're trying to use a floating point, it will give a long precision value. So as you can see out here, how we can address this value, or how we can how we can just set this precision. So what we can do here, my friend, there is a method. There is a method available here that's the round, R-O-U-N-D, round, and you can round everything into a particular decimal up to some precise fractional value. So here round, here you can pass the decimal value, that is, we know that is 3.14, it is a floating, and let me round it to 2 or round it to, let's say, 1, so it will get 3.1. If I use a 2, it will give me the 3.14, or if I use 3, it will give me 3.14 00, whatever. So let us try it out here. See, it's pretty simple. I'm just going to change this one to round, round, like this, and comma, let's say precise to 3, although it is only 2, but let's see. It will give me this answer. So this is also the way you can round it off, or if you're using the strings, that's not an issue, it will automatically. So this tutorial is going a little bit long. Let me explain everything, okay, in short way. So there are many more functions available in decimals. For example, if we use here sqrt, this will give you a square root of a particular decimal. You can also use this exp, exponential, to find the exponential value. You can use log10 function to find the log10. You can just use a function named copy sign. So this will just sign the copy, this one, to the decimal. You can use here exp once again, and once again you can convert a particular floating into a decimal by using a function named from float. You can use fused mathematics, okay, addition, okay, fused addition. So what will happen if you use, for example, decimal 4, 2 and 5, it will do something like 4 multiplied by 2 plus 5, it will give you answer 13. You can also check the finite or infinite value by using these decimals, by using is finite, okay, yeah, this is the finite. You can use is finite function, okay, it will return true or false. Is infinite will return you the false. Is underscore nan, it is not a number, no, it is false, it's a number. So is it normal, particular that we are using out here, is it normal? So it will give you this one, like this, okay. Quantize, this one, not sign, not a number, false. So let's take an example here, my friends. In the next tutorial, we will go with just a 1 or 2 minute example, where we will try to find out the interest by using the formula of simple interest, where P is the principal rate and terms and conditions. So thanks for watching this. This has been going a little bit long, but thanks for watching it, and please do subscribe this channel.